Okay, let's start. And first, I need to review midterm exam next week. So midterm will occur in class on October 21. Okay, next Thursday in this class, and you will have 75 minutes. Okay, you need to prepare one page note, close book, and also. Um, I think this week also I will give the instruction for the midterm exam in the Canvas, and you need to download lockdown browser. Okay, so and I I will upload that midterm questions on the quiz. Okay, you need to into the lockdown browser, go to the quiz, and you can see that questions. Okay, and also next, because I will set the password for this quiz. So next Thursday, for example, special 10:20 a.m. I will give that password, and also I will give additional 15 minutes. Okay, because you need to upload the solutions answers if you write the solution answers, and you need to upload these answers to the Canvas. Okay, Canvas assignment. Okay, there is assignment called midterm exam, and I will give additional 15 minutes to scan and upload. Okay, to the Canvas. Okay, I think this is the basic information regarding the midterm exam. Okay, on the next special on the next Thursday. Okay, in a class, and for the midterm exam, we can see there are 100 points, and okay, later I will discuss that. Yeah, I need to review what's the include. Okay, so before the TCP. Okay, so that is from the into the pipeline protocol. Okay, go back and select repeat. Okay, so there are four type of questions. Okay, first one is short answer, and each question with the 3 points. Okay, so and second one is true and false question, each one with 2 points. Third one is the multiple choice question, each one with 2 points. And last three, okay, there are long answer questions, 3 long answer questions. Okay, later I give the examples, okay, the detailed questions regarding these 3 type of questions. Okay, this is basic policies, basic information for the midterm exam. Any questions? Okay, there are no questions. I need to. Okay, let's review. Okay, that topic regarding the midterm exam, chapter 1, chapter 2, and part of chapter 3. Any question? Okay, no questions. Okay, I need to review that. Another one is after class. Today I need to post a recording, and another one is I will upload this review. Okay, and also give the new homework. This new homework regarding socket programming for the web server. And I will give the longer time, 2 weeks to finish this. Okay, so no questions, and let's check out, okay, the 3 chapters, okay, some important topic, important concept regarding that is the midterm exam. And first one is that in chapter 1, we discussed introduction of internet. Okay, I think we used one figure to introduce what's internet networks, and also we discussed the definition of protocol. Okay, to define some the message. Okay, the format. Okay, the between the 2 devices for the in order the message or the actions or other things. You need to check that definition of the protocol. Second one is that for the internet, we divided that the internet architecture into 2 parts: one network edge and network core. Okay, network edge part is, okay, we user want to use that network edge to connect the edge router. Okay, so there are multiple access network. And for example, from the home access network to the enterprise access network, and to the data center access network, to the mobile access network, and also like the used LTE, Wi-Fi. Okay, and there are different physical medium. Okay, we can consider guided and guided. Okay, the wireless and wireless. Okay, we discussed like some features for the physical mediums. Okay, and like the fiber, copper. Okay, like Wi-Fi or LTE, 5G. Okay, this is the first part for the network edge, which is closer to the user. And the second part is the network core. Okay, we need to consider if we send out a packet to the edge router, and there are multiple routers from the sending router to the receiving router. And for this case, we need to consider each router and how to forward that packet. So for this case, there are two architectures, and the first architecture is the packet switching, and the second one is circuit switching. So what's the difference between the packet switching and circuit switching? So there is the long answer question asks you to compare these two, okay, like your homework. We know the packet switching is great for the burst data, okay, like some special use for the internet, and the circuit switching is for the typically used for the telephone network. Okay, that consider a dedicated resource. Okay, reserve the resource, and packet switching consider shared resource. Okay, packet switching always consists store and forward. Okay, need to receive the total packet, then store in the router's buffer and next to forward to the next router. Okay, and for circuit switching, because that you need to reserve the resource, like the resource maybe like the time, maybe the frequency. Okay, we consider like the TDM or FDM solutions to separate that resource. Okay, and second part is that we discussed the performance. Like there are three performance. First one is the packet delay, including full source packet delay from the processing to the queuing delay to the transmission delay to the propagation delay. You need to consider what's different between the different delays, especially for the transmission delay. Okay, I in a class give an example, and if there, for example, from the source to the destination, if there are one router, right, and we need to deliver the packet with the packet length L, and link transmission rate is R. Okay, for these two links, what's the total transmission delay? So that equals 2 times R over R. Okay, if there are multiple routers, you need also consider how to calculate that delay, transmission delay. Second one is what's the reason for packet loss? Okay, that router buffer size is limited. Okay, so if the buffer overflow, so the router need to drop that packet, which lead to the packet loss. Third one is throughput. Okay, as in previous we discussed the link capacity or link bandwidth that focus on two adjacent nodes. And for throughput, focus on network. Okay, we consider end-to-end source and destination. Okay, then for this case, what's the average end-to-end bit rate? Okay, so this depends on the minimal or limited link capacity. We choose the minimal value from one pass. Okay, next topic is the protocol layer. Okay, and I think this is very important. So, and for the entire protocol stack, there are 5 layers. Okay, from application layer to transport layer to network layer to link layer to physical layer. But also, you need to know each layer what's the service. Okay, and if you know this one, we know we discuss encapsulation. Okay, so if we get a message from application layer and then each layer to add this layer header to implement this layer service. Okay, and the lower layer support the upper layer. For example, transport layer support application layer, network layer support the transport layer, link layer support the
easiest one is
network. Okay, last topic in chapter 1 that regarding the network security. Okay, you need to review special these three attack techniques. So the first one is what's the name for the DOS, how does DOS work, or DDoS work? So denial service or distributed denial service. And also know what's the difference between the packet sniffing and IP spoofing. For the packet sniffing is to capture the frame in the link layer, and like the Wireshark, it will not modify any that packet. And the IP spoofing that is to capture that packet and then change the source IP. Okay, so that is considered the IP spoofing. Okay, this is all the important topic and concept in the chapter 1. Then let's quickly review the chapter 2. For the chapter 2, we focus on the application layer. First we discussed the application layer architecture, like the client server and the peer-to-peer architecture. So what's the difference between the client server and the peer-to-peer? And what's the difference between the client and server? Okay. And the second part is we discussed the socket. Socket like a door, which provide interface that between the application layer process and the transfer layer service architecture. So in the application layer, like the different app, we use the socket to send data and to the internet and receive data from internet. So socket is very important to connect our user space process to that the network kernels, network like a special transfer layer. So another one is in application layer also on top of the transfer layer. And if any apps, we need to choose that the one of the transfer layer protocols, the TCP, UDP. So what's the main difference between the TCP and UDP? After this one, we discussed 4 different the application layer protocols. The first one, web, and we discussed that used HTTP. I think you first use Wireshark to learn that the HTTP protocol format. The second part is this 2 weeks, and you will use to write a socket for the HTTP server. So after this, you are very familiar with HTTP protocols. And for HTTP, use the client server, use the TCP, and there are 2 connections for the HTTP. One is the persistent, another one is the non-persistent. So persistent, so we just consider use the one TCP connection, then we continue to request remaining reference object. If consider non-persistent, that means if we get an HTML file, and then if we want to request a new reference object, we need to create a new TCP. So later also there is long answer question to compare the persistent and non-persistent HTTP. How many RTTs? How long? To get this HTML file and reference objects. The RTT is the round trip time. We need to consider how many of these for the persistent and non-persistent HTTP. And then we discussed about the HTTP's request and response format. I think know the basic information. And HTTP is stateless. How to keep track that history information? We can use the cookie. And the issue for cookies to and also have the privacy issues. And last one is this part. How to reduce the institutional traffic and reduce the round trip time. The solution is we can deploy. I can mute. So I can we can deploy that the web cache near in the institutional, and so this is near the user. So for this case, web cache, we use our web cache can reduce our traffic and response time, and but there still is problem and how to synchronize that web cache and original server. And for this case, we can use the conditional get. Okay, so that is purpose for conditional get. This is our first. And also know, so web server, we always said that the port number is 80. And the second one is that for the electronic mail, and for second app, okay, we know that includes 3 components, like the user agent, mail servers, and SMTP protocols. And special for SMTP protocol, we know also use the client server architecture, use the TCP. And another way is that SMTP just to push the message from sending server, mail server to the receiving mail server. Okay, how to extract, how to get the message. So for this case, we need to use another protocol, mail access protocol, like HTTP or MAP. So you need to know what's the difference between the SMTP and HTTP client. Okay, SMTP to push the message, HTTP to pull the object. So third one is we consider the DNS. Okay, but every day we connect internet, we just type that host name, but the computer need to use the destination IP address to create the TCP connection. Okay, how to transfer from the host name to IP address? We use the DNS. So DNS is the decentralized the database rather than centralized database. Okay, and another one is there are also the other service like give a list name, consider transform domain to authoritative DNS server's name, and consider give a list name for the mail server. And there are 3 type layers for the DNS servers, from the role name, to the TLD to the authority DNS servers. And another one is that we also consider like the user need to use the local DNS server. We can also consider the cache, that TLD server. And then we can use the iterative solution or recursive solution for the DNS resolution. And for the query and reply, okay, there is the one important information here, that is the resource record. Okay, so for the resource record, definitely you need to know there are 4 parameters. And so first one is name, second one is value, third one is type, last one is TTL. So based on the different type, there are different meanings for the name and values. For example, if we type A, okay, that is name is to the host name, value is the IP address. Okay, and if we type NS, okay, that is the name is the domain's name, and the value is name of the authority DNS server's name. Okay, so you need to know different meaning for the different types. Okay, after this one, we discussed the peer-to-peer. We compare the client server and the peer-to-peer architecture for the file distribution time. And we can see if we choose the client server as the increased number of the user, that distribution time also will increase linearly. And if we choose the peer-to-peer, and even though we increase the number of users, okay, that the distribution time can maintain the same value or constant value. Okay, so that means peer-to-peer can scale to the larger network, larger number of users. And then ISMI discussed introduced the detail for the one port BitTorrent, right? For this case, you need to consider if one pair joins this torrent, how to request that file trunk, how to send a file trunk. So how to request that? That is the solution is the Raris first. How to send that file trunk? That considered tit-for-tat. Okay, last application we discussed video streaming. Okay, and with there is video server, there is the client, and for the video streaming, we can say we need specially introduce the industry protocol, the DASH. Okay, dynamic adaptive streaming over HTTP. And for this case, okay, you need to know how that work for the server and a client. For example, server separate video into the video chunks, multiple video chunks. Each video chunk is encoded with the different bit rate. And also there are different copy for that in a different video server in a different place. And there is a manifest file to provide the different URL for that video chunk. And for client, if we get the manifest file and know the URL, and then we can connect one video server and then measure that end-to-end bandwidth or throughput. Based on the bandwidth value, if that is the good bandwidth, we consider higher bit rate. If the bad the bandwidth lower the bandwidth, we consider the small bit rate. This is for the dash. We consider client is smart to determine which bit rate or when and where to request that video chunk. And how to scale to the larger number of the users. We also discussed the content distribution network. And for this case, we give example how to deploy that the video into the different place like the access network. What's the difference between the enter deep and bring home? This is for the video streaming. And then we discuss socket programming this time, and there are maybe 1 or 2 short answer or the multiple choice question or true and false. So regarding you need to compare the TCP and the UDP, for the client server and the client or server that is that socket programming. Know what's the difference between these two. Review that code, and this time also you have homework, special focus on the TCP server part for HTTP protocol. And then the last topic that is chapter 3. We can say just cover to the pipeline protocols. For the TCP, there are no any question regarding the TCP format, the new one. But there is basic question like what's the difference between the UDP and TCP. This we discussed earlier. In the chapter 3, first we discussed in this layer, in the transfer layer, there are just 2 protocols, TCP and UDP. So know what's the difference between the TCP and the UDP. And another way is that if in the transfer layer at the receiver, we get that segment, we need to consider how to direct the segment to the correct socket. So for this case, we need to consider the multiplexing and demultiplexing. And multiplexing is to add header, like network header and transfer header, and here for the demultiplexing at the receiver. Demultiplexing, use that header to direct that segment to the correct, appropriate that socket. And especially for the UDP, we have considered just only use the destination port number to direct the segment. And for the TCP, we use 42, source and destination port number and IP address. This is the multiplexing and demultiplexing information. And after this, we know the common features for TCP and UDP. We first discuss UDP. UDP is very simple and very, that is very small header, the protocols. We discuss that format, and we discuss their very important technique is checksum. How to get that checksum value. And after this, we into the TCP part. And before the TCP, we first discussed reliable data transfer. For this part, you need to review that features or some issues for each of the RDT. For example, for RDT 1.0, so this is assume that is reliable channels. There are no errors, there are no packet loss. And for RDT 2.0, we assume that the channel is bit error. We need to use, for example, how to detect error. So like question like this, you can say we use the checksum to detect error. Review the RDT 1.0 to 3.0. Know the features. You are not good to that check out that the FGSM. In the midterm, you just focus on the features of issue. What's the feature we use for reliable data transfer? And in order for the RDT protocol is the stop and wait. So send or transmit, send a packet, wait for the feedback, then consider to transmit the new packet or retransmit that. And which lead to the very small utilization for the center. How to increase that utilization? We use the pipelining protocol. What is pipelining protocol? It allows the sender to transmit multiple RAC keyed packet. Okay, so based on this idea, we need to use the the more secret numbers, right? And we use the window, for the sender. And so based on that feature, there are two types of protocols: go back in and select repeat. What's the difference between the go back in and select repeat? For example, the go back in use accumulative ACK, and also go back in just a single timer, and also go back in there are no buffer for the receiver. And go back and if their time expired, you need to retransmit all the packet in that window. And select repeat to improve that go back. For example, that use buffer at the receiver to store all the other packet, and also consider individual ACK. So select repeat use multiple timers. Okay, and based on that features, if there is one timer expired, just to transmit that packet rather than to send all the packet in the window. Okay, this is I review used the special 25 minutes to review the topic in the chapter 1, chapter 2, and chapter 3, and regarding that midterm exam. Okay, I think all the questions from the slides. Okay, and another one is let's check out that example for the four type of questions in the midterm exam. And the first one is short answer. You need to write your solution answers, carefully, briefly, clearly. So especially including some keywords, like what is the main reason for the packet loss? Okay, so for this case, you need to consider that if that router's buffer overflow, so there which lead to the packet loss like this. This is the part 1. There are 10 short answer questions, each one with 3 points. And the suggestion is that if you will not know the exact answer, at least to write some related, your answers. And second one is the true and false. This time you will not correct that false question, the answers. And you just to write the truth or false for each of the question. And for this case, you need to review if you want to get the good grade in the part 2, and carefully review that feature for each of protocol or each of the topic. I reviewed that before. For example, like this, packet switching is dedicated, and where the circuit switching is not. So this is the false, because we know the packet switching is shared, where the circuit switching is dedicated. And other question like, the DNS is centralized database, so definitely this is wrong. Check all that some features for that the technical or protocol in the previous topic. And the part 3, there this is the 10 multiple choice questions, single answer. Let's get to choose the which one about SMTP is false. You can check that. Give me the answer. Type on the group chat. Yes, The answer is C. Easy to find. The SMTP that use the TCP rather than the UDP. So very easy. If you know that features, I review that important feature for each protocol. So let's check the last one. Last part. This is important. So I give the same question and just change some parameters. Because this just this question, you will not review the other answer questions. So first one is ask you to review reliable data transfer protocol and go back and select repeat. There are 5 short answers. Know some features, especially how in order to detect the errors, which feature or which technique we need to use. You need to write the checksum. Okay. Another question like is how to let the sender know whether the receiver get that the packet correct or not. So we can use the feedback information like ACK or NAK. Question just like features. We will not ask you to to draw like the FGSM or other things. Just feature of that the RGT and go back and select repeat protocol. Okay, this is first answer question. Review. If you review that, I think this is easy. Second one, regarding the homework, so that compare the packet switching and the circuit switching. Okay, there are several, like this question. I will change that the bandwidth and the probability for the each user transmission, because this time 10, maybe I give that is 20, and each user require a different bit rate. And for this question, I think it's very easy. Okay, if we use the circuit switching, we use the total bandwidth over the each user requires bandwidth. And for the packet switching, you need to know, okay, so the probability, for example, a given user transmitting like 0.1. And then if the question C, like there are 120 users, find a probability at any given time exactly n user, for example, 10 users are transmitting simultaneously. What's that value? So for this case, you just give expression. Okay, for this one, like we choose from 120 to choose the n, and then we use comparability that 0.1 and n. Okay, and 0.9 that is 120 meters. Very easy. Give expression rather than give the final values. That is expression is enough. Okay, this is second answer. Okay, because I just review whether you can get the knowledge for this question. So just give same question and with different parameters. Okay, review this. And the third one is regarding the connection, HTTP connection. Okay, so let's discuss this question. Okay, so in a midterm exam, so I give the same one. Okay, so same description. I just change that value. Okay, for this case, the RDTs and all HTTPs that values. And also we'll change the different small reference object and different multiple TCP connections. Just change that value. But the question is same for the third one, because you will just have the limited time. Okay, I just value you can get this point, this knowledge or not. We will not give the new type of question. And for this case, okay, because this question combines that DNS and HTTP. So first one is we use DNS to get the IP address. So what's the time to get the IP address? Then consider we use the parameter called A to represent that. That A equal RTT 0, okay, and plus RTT, okay, we consider 1, and plus RTT, okay, 2, RTT 3. We get from sum of this, the round trip time for the DNS server. After this, we get IP address, and then we create TCP connection. Okay, and then for the first question is, okay, how many RTT to get the base HTML file? So we know that means use the 2 RTT HTTP. So the first question for like this one, we use the A plus 2, RTT, this HTTP, the H. Okay, very easy. And then, question like, let's review that. So for this is common things, right? It's just get the IP address. And this part, I think if you are not clear about that, you need to review recording for the persistent and non-persistent HTTP. For example, the second one, if you want to get the 10 reference object, and we use the non-persistent HTTP and without a TCP connection, multiple TCP connection. That means we just use single TCP connection. What's that value? So it's very easy. Plus first one get a HTML file to RH, and then there are also the 10 reference object. Because we use non-persistent HTTP and we consider each of the object we need to create TCP connection, we need to consider that the TCP connection we need to get a reference object. So that is okay, 2 times of this RTT HTTP, and then times the 10. Okay, so that truth value. And then next one, I just discussed the first 3. Let's say that if we consider 5 paired connections, okay, so if we consider paired connections, this is common features, A plus this, okay, A plus 2 RTT HTTP, 2 RH. And then, so for this time, okay, how many, okay, the RTHP for the 10 reference object? First one is we use the 2, we can say RTHP, okay, 2 RTTHP to get 5. Total is 10 object. So we just use the 2 plus 2 RTTHP to get a 10 reference object. So that's very easy. And then you consider like the questions 4, the persistent. Persistent very easy. So that just continue to receive that. So that from the 2 RTT to become 1 RTT. Okay, other thing is same. Okay, because it will not create the TCP connection again. That use previous TCP connection to just request a reference object. Okay, I can give that solutions. And also you can understand this for the special. And for the midterm exam, I will change that parameter like 5 to 4 or 3. Okay, this is 10 reference object. Maybe that is this, the 12, 11, like this. You need to understand how to calculate this. Okay, if you understand this, that's very easy. Maybe, okay, 2 or 3 minutes, you can finish this question. Okay, I think I finished all the review for the, okay, that is the midterm exam. So any questions regarding the midterm exam? My suggestion is, okay, you can prepare, okay, to review the the slides, okay, carefully to special, okay, mark some features, okay, for each protocol, each technique. Any question regarding this review of the midterm exam? Later, after class, I will post these slides. Any question? And this time also I post recordings. No question? Okay, the no question, let's to discuss our new topic in the chapter 3. Okay, let's check. Okay, discuss from here. On the last class, I think we discussed the TCP, right? We discussed especially the TCP format, okay, including the source and destination port number, and including ACK, the secret number and ACK number. Know what's meaning for the TCP secret number and ACK number, and the format also including some parameter for the contract control, for the flow control, and also include checksum. And the second part is we discussed for the last class. After we introduced the secret number, we discussed how to estimate, how to set the timeout interval value. For this case, we used the filter, right, to smooth that data. Okay, we said that the estimate are the RTT plus, okay, 4 time division RTT to set a timeout value, which is the dynamic variable. And after this one, we designed that TCP reliable data, the reliable data transfer for the TCP. Okay, that use the pipeline protocol. Most of feature like the go backend that use single timer, use a cumulative ACK. Okay, that just retransmit this the oldest ACK packet. And so other one is that for the receiver also that use the similar thing like go back in. Okay, there is back secret number, and we can give that feedback, right? So and if not there is gap, right? So we consider this auto order. We just give the duplicate that ACK, okay? And if that get the expansion number, we can slide that the pointer. okay, for the TCP. And we also use timer to retransmit that. But how to transmit that faster? We consider the TCP fast transmission. Okay, if sender gets 3 additional ACK, same ACK, so we consider that packet loss. We retransmit that sequence numbers packet. Okay, so this is regarding we also discussed several scenarios for to validate that the reliable data transfer for the TCP, like the lost ACK or premature that the ACK, or like the earlier, the lost ACK. For all the cases, TCP protocol is correct. Okay, second part is we discussed the TCP and the reliable data transfer protocol, and we also special focus on like the flow control and part. Flow control is idea is receiver control the sender so that the sender will not overwhelm receiver's buffer by sending too fast and too more data. And for this idea is we use that one value, the RWND, we insert that value to represent a valuable number of the bits in that receiver's buffer. Okay, so we need to receiver need to notify the sender, so need to limit that window size smaller than this available space in the receiver buffer. Okay, so these solutions. Another one is last class we discussed the TCP connection measurement. We know the two-way is not enough, and we give some scenario why we need to consider the special three-way. The reason is that if we just consider two-way, there is problem like half open connection. Maybe the client leave and the server current to respond that message. Another case is that so we can say client leave after this time point, and server received the duplicate packet, the duplicate data accept. And for this case, we discussed, we use three-way because we need to guarantee the client server both sides are ready to send and receive data. But we want to provide that full duplex communication. Sender send data, and the receiver also send data. So for this case, let's check out that three-way handshaking. First one is, we check that code, the client, to create client socket, TCP socket, and the server also creates the server socket, and also bound that one port number, and also listen the channel. If there is the connection, then the server need to use accept to create the connection socket. Let's see. Connection. There is connection. There is if that connection, so that means the client will send that the TCP SYN message, and will the random sequence number, give the sequence number X, and set of SYN bit is equal 1. That means client want to create connection, and the server gets this information and will into the SYN received state and give feedback for the SYN ACK bit 1, and also response that sequence number X. That is ACK number is X plus 1. And after this, the server also need to know the client will also be ready to response data. So that he also created the SYN bit 1, sequence number is Y. So server need to check that. And then the client get the information, know server current that is live and is ready to respond the data. And we can say server is ready. And then client also need let the server know the client also is ready. So the client this time just responds the ACK 1, bit 1, and responding that sequence number Y. So give it Y plus 1. If the server get this ACK Y, then know the client is live. That client is ready to response data. So after this, the server is established, and after this one, the client is established. So this is the one way, second way, third way. So three-way handshaking to guarantee both sides are ready to respond to the data. How to close that? We also want to use another the flag value FIN bit, okay, to notify. For example, client want to close that, and the client to use FIN bit to let the server know the client need to close this connection. And then the server just give the response ACK for that FIN. Okay, so. And here is we finished that the basic features for the TCP. And then let's discuss our last topic for the conject control. For the conject control, okay, in this part, okay, we previously discussed the TCP, okay, provide reliable in order batch streaming, and also include 3 handshaking we discussed earlier, and also include flow control and conject control. Flow control we discussed last class. Okay, sender will not overwhelm receiver's buffer. Okay, so that's just regarding the receiver buffer. So this is very simple. We just give the feedback. Okay, RWND, this value, available space of the receiver buffer. Okay, then the sender just control that limited that the windows. But for conject control, this is challenge regarding network buffer. Okay, let's see. So for this case, okay, so there are many modules are sending too much data too fast for network to handle. So for this case, we can say that regarding the network. So conject control is the more complex. Okay, so there is some, for example, the router part, there may be the queuing delay for the longer delay, or the buffer overflow at the router to drop the packet. Okay, for this case, okay, we need to consider how to address that congestion in the network. If, for example, if the sender choose one path from source to the destination, there are multiple routers in this path. Okay, and for this case, if we send more data into this network, so maybe some router will be congested. Okay, if they're congested, we can say maybe the router drops that packet, maybe there are longer delay. So how to address this longer delay or packet loss issues? We need to design conject control protocols. So this is totally different from the flow control. And this is also top 10 problem in computer network area. Okay. Okay, let's say flow control like one sender too fast for the receiver. This is receiver. And conject control is too many senders and send too much data into the network, into this network. Okay, the highway. So for this one, how to handle that traffic, how to handle that congestion in the network. Okay, so definitely compare this, and this conject control is more challenging. Before discussing that the conject control, let's first review some scenario, some cost or reason for the congestion. Okay, we from the simplest to the real case. Okay, first one is if we just consider one router. Okay, this one, and but this router connect multiple devices, host A, host B, right? And for this case, we consider there one router and there is the infinite the buffers in that router, and input and output link capacities are. And there are two flows. One is from host A to host C, and one is from host B to host D. Okay, and this link share that link capacity. And if we want to transmit data, in the application layer, and then for the at receiver part, we need to receive get that the throughput is lambda. The out. We check out what's the relationship between the lambda in and the lambda out. And this time we just consider this simple is there are no retransmission. So and for this case, and what happens if arrival rate approach R over 2? This figure we can show that the X is lambda in and Y is the throughput lambda out. If we increase lambda in, linearly, and lambda also linear increase. And linear increase lambda in, and also we consider linear increase at lambda out. And if that approach that R over 2 special, if lemma in is larger than R over 2, so because consider fairness of the allocating that the resource link capacity, because there are two links, so each link just shared R over 2. So after that lambda in is larger than R over 2, that the throughput here just support that R over 2. Because if larger, so the maximum value just R over 2. And based on that, the throughput, if we discuss that throughput, then let's check the delay, okay, and the special queuing delay for that router. And if we increase the lambda in, that is like the traffic intensity, and the delay also increase. If that proved R over 2, that delay become infinity. Okay, so this is the first case. We consider, okay, there are no packet loss because we assume there is infinity buffer. Okay, then let's check for the scenario, okay, beyond the scenario 1, let's check the scenario 2. There is also one router, but this time the limited buffer size. Okay, this is limited buffer size. So maybe that if the buffer or the router overflows, I need to consider drop that packet. Okay, for this case, okay, the sender need to retransmit lost order packet. So that means, okay, lambda in, okay, for the application layer, lambda in equal lambda out. We need to TCP reliable data transfer. We send, okay, for example, the best data, we need to receive 10 best data. But in the transfer layer, okay, this is different. In the transfer layer, because transfer layer need to retransmit more data. Okay, so for example, the first packet, if that lost, we need to retransmit the first packet again. So lambda in prime, this is larger or equal lambda in. So for this case, okay, this is including original data and plus the retransmission data. And the lambda out just equals the original data. Okay, for this feature, okay, let's check that. Okay, so this is first case, and if we know the perfect knowledge, for example, sender send only the buffer available. So this is like this one. And the second case, that just know some perfect the knowledge. Okay, and if there are some retransmission packet loss, and for this case, let's see, the first time, okay, that send data. If a variable space, that is to go to the destination. And second time, and if we transmit data, okay, transmit that, and no buffer space, drop that. And then I need to retransmit this again. And so that means for the same data, we transmit twice. And for that feature, we can say, compare previous one, okay, before the R over 2, this is we consider the transfer layer, the data, lambda in prime. If we increase that special, if we approach the largest one, the R over 2, and the throughput here, that is smaller than the R over 2, okay, because we can see, and for the throughput part, and the lambda in, okay, the in prime is larger than the lambda out. Okay, this value is larger than this. That means we need to transmit more packet to deliver original data. Okay, the figure like this. Okay, special approach that is the limitation of the link capacity. So there is some packet loss. So the output, the throughput will be smaller than R over 2. And for this case, we can say that with the capacity because of that retransmission. And then we also consider some unneeded duplicate packet. And for this case, okay, we need to handle some premature, some timeout value and packet loss. These two copies. And for this one, also I need to reduce the lambda out. Okay, so for the real case, the throughput is smaller than the R over 2. So that need to address that duplicate packet or that the packet loss. Okay, and for this case, let's consider last one, scenario 3. Scenario 3 is, for the real case, there are multiple, the sender and multiple receiver. Also, there are multiple routers, multi hops. And for this case, for example, from host A to host C, there are two router limited buffers. And also, if we send data, we need to consider lambda in prime, the summary transmission. And at the same time, we consider transmit data from the B to D, it's another path. And also from the specialty, here is from D to B and from B to D, and choose another path. Okay. And for the conjunction level, also like from the C to A. Okay, each one is shared by the multiple connections. Okay, and for this case, if what happens as the lambda in and lambda in prime increase? Okay, special that as the right this lambda increase. Okay, we can see the blue packet at the upperly that the upper Q are dropped. Okay, so and for this one, because that blue throughput become the 0. Okay, if we consider the share that millions in the limited space. And for the real case, let's consider that for the lambda out, and equal, like this curve. For that, this is the nonlinear curve. So before one value, that lambda out also will increase. And we continue to increase that lambda in prime, so that the lambda out will decrease all into the 0. The reason is that if rotor current is congest, like this case, if rotor current congest, there's no space to another link, another lambda out. So finally, that means rotor current congest. And if you send more data, for example, from host D to host B, definitely the rotor will drop all that packet. So that throughput becomes 0 for the blue throughput. So how to release that issues? We just can decrease, if we can decrease that lambda in prime, rather than continue increase that. This is a solution that means in order to improve that throughput, network throughput, we need to set that lambda in prime properly. So based on environment, based on network routers congestion level, sometimes if it's small congestion, we can increase that value. And if it congest, we need to decrease that value. So this is solutions. So we consider we need to control that sending rate. So which parameter regarding that sending rate, we know for the sender, for the TCP, there is the window size. There one. And we need to address that window size, to control the sending rate. Finally, we also can control that the network congestion level in the internet. There's some insight here. So first one is that the throughput can never exceed the capacity. The capacity R/2, definitely the throughput is the smaller or equal that to the throughut R/2 for this connection, this link. Another one is as throughput approached, like this, approach this one. Lambda approach R/2. The delay increase, also become infinity. And another one is that third insight is this, some packet loss or retransmission also decrease effective throughput. For example, this one, because of some packet loss issues for the retransmission. Another one is some unneeded duplicate packet for the premature timeout value also continue to decrease that effective throughput. And last one is that upstream transmission capacity or buffering risk for the packet, for the downstream. The reason is that if we continue to increase that the input rate, and which lead to the congestion, hair congestion for the router. So for another connection, so there is no space for that router to forward that packet. So for this is the real case, the final that is the throughput. So the input and output. So sometimes we need to increase that, sometimes we need to decrease that. Okay, compare the previous case. If we increase that, we can increase the throughput. But here we can see if we continue to increase that, okay, sometimes the throughput will decrease. And what's the solution? Okay, for the contract control, we need to discuss the protocol for the contract control. And for this case, okay, first there are two types of things. First one is there is no explicit feedback from network. Okay, just consider end-to-end contract control. And the second one is we consider that this is first case, we send data from the client and the server give feedback ACK from this. How to do the contract control? We based on the feedback, based on ACK. We get ACK, we can increase window size. Okay, if time expired, we can decrease window size. Okay, or we get a 3-duplicate ACK, we can decrease window size. This is the idea. So we use that feedback ACK or timer to represent or to reflect that real case for the internet, because we cannot measure the congestion level for the routers, the multiple routers, but we can use that performance parameters to evaluate current internet congestion. Okay, so that is end-to-end congestion, the contract control. Okay, so the congestion is inferred from the observe that packet loss and delay round trip time. Okay, this is the approach by the TCP part. And the second one, this is first one. And the second one is the network. This is cross-layer network assistant contract control. So this solution, if you check out the TCP format, there is some value, like ECN, and ECE, ECN. So for that case is that the router, provide some direct feedback to the sender. Okay, if this router, for example, if this congest, we can update that value. Let receiver know, and receiver also updates some flag value or give feedback for the sender. Okay, so this one is network. Okay, this router help. Okay, give the additional information. Let the sender know this router is congested. You need to decrease the window size, decrease the sending rate. Okay, so this is router may indicate contact level or explicitly set a sending rate. Okay, we can see. Okay. Send data without congestion. Okay, we give the expressive congestion information like the TCP ECN or ATM or DEC bit protocol. Use this idea. And a special current, I think for our internet architecture, the figures we discussed, there is one access network called a data center. For the data center, there are the millions of the servers. Okay, there are multiple switches. For that case, we want to implement contract control. We need to use we call that a DC TCP. Use that a network assistant contract control. Okay, so we know that idea. We know the inside of congestion or the reason of congestion. Okay, we know there are two types of the contract control protocol. Okay, end-to-end and the network assistant. So first one is let's check out the end-to-end solutions. So this is very famous one. Okay, AIMD protocol. The approach is that the sender can increase the sending rate until the packet loss occurs, and then decrease sending rate on the packet loss event. And how to understand that? Okay, we use that figure. X is time, Y is the sending rate of the sending window. First one is that we can see the curve. Okay, sending rate is dynamic. The idea is that if we get ACK, correct ACK, so we can increase window size. If we find the 3-duplicate ACK from here, we can cut window size in half. If we find that packet loss, we cut window size in half. Okay, cut window size in half. Okay, we can say, so that means if there are packet loss, we need to set that half of the window, okay, to decrease additive increase. Okay, that means, okay, we can increase sending rate by 1 maximal segment size if we get every RTT, okay, get feedback RTT until the packet loss is detected. And what is the multiplicate the decrease? That means if find a packet loss, for example, get 3 duplicate ACK, we need to cut the sending rate in half. Okay, so that means contrast. The network is contrast. So we need to decrease that window in half, give it a larger value, decrease. So based on these solutions, we can see the AMD that is to prove that for the bandwidth. Okay, for this is also dynamic protocol. And for this case, okay, especially for the sending rate is to cut window size in half. Okay, we consider like the get a triple duplicate ACK, or we consider TCP random. Another way is we also can cut window size in one MSS. So for this case, because of that the time out value, okay, the two solutions we assume that the packet loss. One is to get 3 additional ACK. Second one is we consider the time expired after the time out value or TCP table. Okay, why AMD? So this is very simple decentralized synchronization protocols or algorithm, and also that can provide this dynamic, right, optimize that congestion flow rate, okay, based on the network situation, the congestion level, okay. So this protocol also for the have some the expanded the stability properties. Okay, so because we just used increase the decrease that one size in half. Later in the next class we'll analyze that. Okay, let's check out that TCP congestion control detail. This is we can say this is last byte ACK. Okay, also get that ACK, and this is send. Okay, an ACK. This is available space. This is window size CWND. Okay, we here is we use CWND. Instead of N. So this is like N. Previous N. Okay, so this is sent but not yet ACK in flight packet. Okay, this is the last byte sent. This is available but not used. Okay, and for this case, that means if we know that window, we need to, for the congestion control, that means we need to limit that sending rate, like use the last byte, okay, send to minus that last byte ACK. Okay, so this yellow part, this sending rate need to smaller than this window and or CWND. So that means for the congestion control, we need to set that value, CWND value. So this is dynamically adjusted to respond that network congestion level. Okay, so based on these things, if we know that the sending rate is the CWND, also we can estimate that the sending rate equals that window, the data CWND over round trip time, okay, RTT. So that equals the bytes per second. Okay, let's check that. Okay, especially for the 3-stage for the TCP congestion control. First one we call that a slow start. Okay, that means in the beginning we just set the window size is 1, send 1 segment. Okay, the maximal segment size. And then if get ACK feedback for every RTT, we can double that, like this. Send 1 segment, get feedback. We can second time send 2, third time the 4, then to the 8. So for that feature, for the slow start, that feature is initial rate is slow, is small, but ramps up exponentially fast. Okay, we can double for every receiving the ACK. And then, okay, so from the slow start to into the congestion avoidance, that means we are not double that again. So after one value, if one, for example, this window size is larger than one threshold, okay, and then we need to linear increase that rather than non-linear. Non-linear is increased exponentially. Okay, so when should the exponential increase switch to linear? Okay, so that is we consider that window size get to half of the value before the timeout. So set that there is threshold. After threshold, we can set that linear. Okay, we can increase that linear. So this means the threshold, SS threshold, also is dynamic value. Okay, so traditionally we can set that is half of the CWND, the last one, last the packet loss. Okay, for example, and there is the packet loss. If this case even is the packet loss, okay, special is time expired, reach the time out value. So then we need to set that at 1. So this protocol is TCP Tahoe. Another way is that if that is the 3-bit ACK, and then we set that window size half of the previous, there are 12, we set that is 6. Okay, the TCP random. Okay, this is the basic information for the TCP contract control. And special, we can say, for the TCP contract control, the including 3 stage, okay, slow start, and congestion avoidance, and fast recovery. And next class, I use one figure to discuss this one. For example, in the beginning, that in the slow start, and for this case, we can say first, and there are no event, and we just set window size 1, and threshold is this, duplicate ACK is there. Okay, if get that the duplicate ACK, we can consider plus ACK count value. If we get an ACK, new ACK, we can increase that window, double that window, and set that duplicate ACK equals 0. And if that window set is larger than threshold, we can jump the states from slow start to the contract avoidance, right? And then for the contract avoidance is that for get each of ACK, we just increase linearly, okay? And get duplicate ACK also we can plus this value. And if their time expired, and we can set that is 1, window size is 1. And threshold is half of previous. And if we get 3 duplicate ACK that into the new state, we call that a fast recovery. So for the fast recovery, so that means that window current, that is just we can say the equal first set threshold, then the window equals threshold plus 3. Okay, and for this case, if get a new ACK, okay, we can also go back to contract avoidance. Consider timeout value, we set that 1. Okay, and from slow start, get 3 duplicate ACK, also go to the fast recovery. So there are 3 states. And next class, I think I use figure to show how to mark for each of the points which belong which state, slow start, contract avoidance, and fast recovery. Especially in the contract avoidance regarding AIMD, this is the stable state. Okay, and that is features. Okay, let's see. Today we mainly focus on like the TCP contract controls. I first discussed AIMD. Okay, and that regarding contract avoidance, and then I discussed this 3 stage. Okay, and for each stage, and that regarding for the different that contraction level. And also we use CWND to control that, to limit that sending rate. And this value, this window also can lead to the different congestion level for the routers. For example, if window larger, we send more data into network, and maybe that will congest. And the next time we need to consider based on feedback. For example, if get the 3 duplicate ACK, and then we can reduce that this window set CWND. Okay, and also there are 3 stage, and the next class let's first review the stage. And otherwise I use one figure to discuss this how to use this FGSM to understand that current that value, for example, in the different state. Like this figure, you need to consider this is the slow start, and this report. And these 3 points that I consider contract avoidance. And this one, okay, for this case, that is, okay, we can say this reason even that is the timeout value. And for this case, this is like the 3-tuple ACK. And into just linear increase. And but for the go to the set 1, then we just go to the slow start. After the threshold, we can go to the linear contract avoidance. So we need to know for each point that belongs to which state, how to set that threshold. For example, new threshold equals half of the previous window set. Then 6, this is half of the 12. Okay, how to set that the threshold? Okay, next class I use the one example to discuss that. Okay, let's finish here. Later I will post the midterm exam review and give the recording for this class and also post the new homework. Okay, thank you. Let's discuss the next class. Bye-bye. See you next class.